Hello, my name is Anam Wafa, and I'm the applications engineer here at New Tech Group. And today, in this video, I'm going over a kind of a brief description of what exactly is multispectral imaging, what is the VideometerLab unit, and how can this technology help you, the viewer, in your everyday applications and whatever problems you might have. How can this help solve those and kind of speed up the process that you might currently be going through? Multispectral imaging, in very simple terms, is using a specialized camera, using different wavelengths of light, and capturing data from a sample. So we take an image using lights from UV all the way up to near infrared, and the data that's acquired then from your sample is then analyzed for points that cannot be seen by the naked eye. So in very simple terms, that's the definition of multispectral imaging. Now, what exactly is the VideometerLab unit? You can see that in front of us right now. This is the unit right here. It's fairly small. It doesn't weigh a lot. It's I'd say approximately 30 pounds. But what's special about this unit is threefold. The first thing is that we have a specialized camera at the very top that is capturing image of the product or your sample. The second thing, is the different types of lights that are being used to produce UV all the way up to near infrared. And the last thing is that we are doing everything in a very controlled environment. So you can see this kind of very obvious globe shape here. What's inside this globe is a coating that allows light to become very homogeneous. So whenever the light's strobing inside the unit, we eliminate shadows and highlights and things like that due to the coating that's inside. So those are the features of the physical unit that make it very impressive and very effective. What goes hand in hand with the unit is a very powerful software that's part of the system. So looking at a diagram of the unit, you can see that the lights go around the circumference of the unit, and we have up to 20 different wavelengths. The unit utilizes lighting from 360 nanometer all the way up to 1050. We have a very high resolution camera that allows us to get very detailed with each pixel within our sample, so we can get a lot more data out of it. Very homogeneous and diffuse illumination, that's due to the coating that we have inside the unit, and it takes very little time to analyze each and every sample. So switching over now to the software, we take an image of our sample. So this is an image of corn kernels. Again, I'm going over an example that is very kind of generic, and you can kind of figure out from this run through on how you can apply it to your specific application. This unit is used in the industry throughout, several different types of industries, from pharmaceuticals to counterfeit detection to coding quantification. So that, for example, let's say if you're doing dog food and there's some type of coating on it, you need to quantify if the right amount of coating is on there. This software and this unit can definitely do that without a sweat. So it will tell you, okay, there's 90% of this specific coating on there, or there's 50%, and from there you can flag it to either be approved or be denied. So again, this has very wide range of uses. So from coding, quantification to sizing and quality control. So if you're working in a pharmaceutical factory and you're taking images of different batches of tablets coming out, this unit will tell you if it's meeting certain criteria for roundness, for the length, for the width. If something is out of spec, it can flag it. So it's something that can be trained for each and every single type of application. It can be used in dermatology for things that are not seen on the skin, to measurements of areas. So for example, patients that have psoriasis, sometimes it's not visible to the naked eye, but to this unit, since it's looking at spectral data, we can look at the skin and quantify the affected area. And of course, grains and seeds, and for agricultural use, which is kind of what we're doing right now as a very generic topic. So we're looking at corn kernels. Now, to the naked eye, this is what we would see. We would see corn kernels that are all very similar. Nothing really stands out amongst any of them. But what I have done is I have coated some of the kernels in a little bit of a kind of a reflective solution. So to the naked eye, it doesn't show up as anything, but to the unit itself, it's able to pick up on these kind of slight, subtle differences on the surface. So this is kind of akin to where seeds and grains will sometimes get some fungi or bacteria or some type of infection that some user would need to sit there and kind of sift through it and see if that particular sample is infected. Now, that's a very time-consuming type of a task, to be able to sit there and kind of comb through it and look for very subtle kind of changes. And we can zoom in and out. You can see that really nothing stands out, particularly with any of these corn kernels. But to have to sit there and do it one by one and then be able to, I guess, quantify what percentage is infected and what's not is an even greater and more challenging task. But with this unit and this software, all we are simply doing is we are painting the different portions. So under the different wavelengths, now we can see that certain kernels stand out. So you can see that the brighter portions on the kernels, those are the portions that we are calling infected. So to be able to look at that with the naked eye would be near impossible. And then to quantify how much of it is infected, how much of this batch is uninfected, is even more difficult. So we've simply just painted the corn kernels, the infection, the background. And from there, we are able to separate each one of those kernels into its different, as the software calls it, blobs or single items. So we can look at the features and specifications for each separate kernel. So for example, the very first one I clicked on, we can see its area, we can see its LAB values, we can see the hue, intensity, length, roundness, saturation, width. So again, you can see how this would apply to a lot of different types of applications, not just corn kernels, but to tablets, to pills, to whatever type of products you might be dealing with that deals with kind of numbers. Now, these aren't the only features available. We have several hundred different features available that you can select from, but these are the default. So from here, we can train the software to give us a readout on what percentage of our sample is infected, what percentage is uninfected. So we created a very simple type of recipe. This is a recipe that a day-to-day user would use. So somebody standing out in the line that is watching the different batches of, let's say, for example, right now, corn kernels go by. So every once in a while, he has to grab a cupful and test it. So with this unit, this can be mounted on the line, so you may not even have a need for that user to be standing there, because it would automatically take pictures and give you the data. But for example, we took a batch of corn kernels, we put it under the unit, and all we have to do at that point is click the run button. So within 4 to 5 seconds, it will analyze our sample and give us the necessary data that we are looking for. So in this case, we're looking for what area is infected, how much of it is infected, how much of it is not infected. So you can see within a few seconds we get some very useful data. On the left hand side, we see our image. So on the top left, we see our raw image. So this is what our eye would see. And then on the bottom left, we would see kind of an animated visual image of where the infection lies, where the healthy portions are, and on the right side we see the data that we're looking for. So we can see we have our percentage uninfected area. So 99.5% of our corn is uninfected. Okay, so that means that approximately 0.5% of it has an infection. We also see how many corn kernels or blobs that it counted. And again, this is just a very simple kind of a example. We can put a lot more data in here, so we can show different points of roundness. We can show length, width. We can reject things. We can show it in red, green, whatever the requirements are. This software can do. But this is just one of the applications. And this is to kind of just get you thinking on what other possibilities there may be for your specific application, not just for corn kernels, but for tablets, for skin, for doing measurements of sizing. So if certain things don't meet the specific sizing criteria, it's rejected or it's approved. So again, this is just to give you kind of an idea of where you can lead your applications towards. So if you have any questions regarding this instrument or what's possible for your specific application, definitely do not hesitate to contact us, and we'll be glad to help out in any way possible.